Okay, so we're going to look at the conjugate of a complex number. So we know a complex number is if z is equal to a plus b, where a, b are an element of the reals, and I squared is equal to minus 1, then the conjugate of z is denoted as z, and it has a little line on the top, okay, and is defined as, so my z, my conjugate, just that little line on top, is equal to a minus bi. So the only difference is, we know that z is equal to a plus bi, the conjugate is a minus bi. The imaginary sign is the only one that changes. So here I have z is equal to minus 2 plus 3i. The conjugate of that is equal to minus 2 minus 3i. Another example is if I have z1 is equal to 2 minus 2i, and z2 is equal to minus 4i, z3 is equal to 5. I'm asked to find the conjugate of z1, so find my conjugate z1. That's equal to 2, you only change the imaginary sign, to 2 plus 2i. Then I'm asked to find the conjugate of z2, so z2 is minus 4i, so that's going to be 0 plus 4i, and find the conjugate of z3 is just going to stay as 5. Then it asks me to plot them on the Argand diagram. So if I plot them, my ruler, on the Argand diagram, along the horizontal I have my reals, and my y-axis is my imaginary. So the first one is 2 plus 2i, so 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. So the first one I'm plotting is 2 minus 2i, so I always start here, so go in the door and down here to minus 2i. That is the conjugate of z1. The next one, the conjugate of z2 is 0 plus, oh sorry, I'm actually just after plotting z1, that's not the conjugate. The conjugate of z1 is 2 plus 2i. So 2 plus 2i is up here. So conjugate z1, conjugate of z2 is 0 plus 4i. So 0 plus 4i is here. And the conjugate of z3 is just 5. So that's here. And that's the first example done. Okay, so the next example here, I'm given that z is equal to 1 plus 2i. I'm asked to find my conjugate, find z plus the conjugate, find z minus my conjugate, and find z times my conjugate. So I'm going to find my conjugate first. So to find my conjugate, I always just change the sign of the imaginary number. So this is going to become 1 minus 2i. That's part I. Part 2 then is z plus the conjugate. So z plus my conjugate is equal to, my z is 1 plus 2i, plus my conjugate, which we just found, is 1 minus 2i. So I have then 1 plus 2i plus 1 minus 2i, and my answer is going to be 1 plus 1 is 2, plus 2i minus 2i, that's gone. So my answer is just 2. The next part then, part 3, it is z minus my conjugate. So z minus my conjugate, I'm filling in for z, so that's 1 plus 2i in my bracket, minus my conjugate is 1 minus 2i. So I have 1 plus 2i, minus by plus gives me minus 1, minus by minus gives me plus 2i. So my answer then, 1 take away 1 is 0, 2i plus 2i is 4i. Part 3, that was part 3. Part 4 is z times the conjugate of z. So my z, first of all, is 1 plus 2i times my conjugate 1 minus 2i. So I'm multiplying out brackets, so the first thing I need to do is I need to split the brackets. So it's my first term, which is 1, times everything in my second bracket. My second term, which is plus 2i, times everything in my second bracket. 1 times 1 gives me 1. 1 times minus 2i gives me minus 2i. 2i times 1 gives me plus 2i. 2i times minus 2i gives me minus 4i squared. Minus plus, that's gone. 1 minus 4, I squared is minus 1. So it's equal to 1 minus by minus gives me plus 4. And my answer then is 5. So that's it done there. Part B then is asking for me to plot them on my diagram. So here I have z is 1 plus 2i, so 1 plus 2i is up here, and then z plus the conjugate is 2 plus 0i, so I'm going in here, so 2 plus 0i is just here, and then the last one is z minus conjugate, we just got 4i, so that's up here. It asks me then to describe how z is transformed by each of the operation in part A. So here is z, and I'm looking at to see how are they transformed. So what we can say then, so the conjugate is a reflection of z in the real axis. Okay, so my conjugate, so if this is my conjugate here and this is my z, they're just actually reflecting one another. The only difference is that this is minus 2i, this is plus 2i. And then it says z minus z plus the conjugate, so is a vertical projection of z onto the real axis followed by a translation of one of the units to the right. Okay, so that is just z plus the conjugate here. So we have, instead of 1, we're going over 1 unit to the right because 1, this is 2, and we're also projecting here. Z minus my conjugate is a horizontal projection of z onto the imaginary axis followed by translation 2 units upwards. So we're moving onto my imaginary axis and we're going 1, 2 units up. Then z multiplied by the conjugate, so that's down over here. So this is what we're what's happening here basically is we are now after going onto the real axis. Okay, so it's projection of z onto the real axis followed by a translation of 4 units to the right. So we're gone down here onto the real and we're going 4 units to the right. So 1, 2, 3, 4. Don't worry if we don't get translations, I will be able to explain them again when we are in school. So what I'm going to do is another example here. So exercise 8.6. I'm going to start off by doing question 2. Okay, so question 2 says z1 is equal to 7 plus 5i and z2 is equal to 2 plus I. So I'm asked to find the conjugate of z1. So conjugate z1 is equal to z minus 5i. The next one then, part 2, says the conjugate of z2, and that's 2 minus I. So I only ever change the sign of my imaginary number. Part 3 says the conjugate of z1 plus the conjugate of z2. So my conjugate of z1 is 7 minus 5i. My conjugate of z2 is 2 minus I. So I have 7 minus 5i plus 2 minus I. My final answer then, 7 plus 2 is 9, minus 5i minus I is minus 6i. and that's part 3. Part 4 then asks me to add z2 plus the conjugate z2. So z2 is 2 plus I plus my conjugate of z2 is 2 minus I. So I have 2 plus I plus 2 minus I plus I minus I, that's gone. So my answer then is just 4. Z1 plus my conjugate Z1 is equal to, so I have 7 plus 5I plus my conjugate is 7 minus 5I. So here I have then 7 plus 5I plus 7 plus by minus still gives me minus 5I. Plus 5I minus 5I, they're cancelled, and my answer is just 14. So as we can see there, anytime we're adding the complex number with its conjugate, we're always eliminating my imaginary number.